All right, here's the part about from the Emulsion lab. And so what you should have had is you have the time that it takes to re-equilibrate. All right. And so you have the different runs. It'll start and then it'll go to reach equilibrium. And you didn't have any plastic, but there's a video on Brightspace where you can look at the plastic to see how they respond. And here you can see that we have the orange at the bottom and the yellow at the top, and kind of use that as your guide actually. So you don't need the video. Okay, so now that you have the data, then you're going to go in Excel and you're going to enter the temperature in Celsius and then calculate the temperature in Kelvin, calculate the inverse temperature in Kelvin, enter the demulsification time for each trial, and then calculate the average demulsification. And now everything before should be straightforward. You calculate the rate, and it's just the inverse of it. All right. So what you get in E, take the inverse, that gives us our rate. And then you're going to calculate the natural log of that rate. All right. And that gets you to G. So they're all just little steps. Now in 2, you're going to make that plot ln k versus temperature and add a trend line. You should have a downward trend. All right. And so that slope is going to equal negative EA over R. If you don't have a downward slope, then look for like some data points, that error that would help you to kind of fit that trend. All right. Now, once you add the trend line, that slope is going to equal the energy of activation over R. So again, you're going to take your trend line here and then set it equal to set the slope equal to EA over R. And so it's a simple rearrangement to get this energy of activation, and then pay attention to the units. All right. And then lastly, how the addition of soap change the rate of demulsification. So that I talked about in pre-lab lecture. So what you don't need to actually do any calculations with it. You can just empirically see it. All right. And so hopefully you saw that. And if not, just reach out to me. So now the post-lab questions. So how does the density of it change? Just thinking back again, the first semester idea of density, explain why the plastic moved through it. So, and then 3 now is just a standard energy of activation calculation. So you can use the Arrhenius equation, the LM plot, similar to the Clausius-Clapeyron in chapter 11. And then 4, 5, and 6 is just plastic, just looking up, get you to think about it. All right, a short, easy one, hopefully.